Hello, Glendale Community College. We're going to balance some more complicated reactions now. So this is balancing reactions number 2 with Dr. Kim. We're going to balance this reaction first. Let's look at this reaction, see if you can decide what type of reaction it is. Maybe you know already. It is a combustion reaction, right? Yeah, it's a combustion reaction because we need oxygen gas to support the flame when we burn a hydrocarbon. And we always produce CO2 gas and H2O gas when we have combustion reactions. Awesome. Okay, so we're going to balance this combustion reaction. Now there's a trick for combustion reactions, and that is we are going to balance the oxygens last. We do that because they're by themselves. Usually when there's an element by itself, it's easiest to do it last. So we're going to balance the oxygens last in combustion reactions. Remember, for any reaction, we need to have the same number of atoms on both sides. So I'm going to put an equals here under the arrow. So I'm going to do this a visual way. We have 6 carbons and 8 hydrogens. So I'm going to draw a little picture underneath. We have 2 oxygens. And then on this side, we have a carbon with 2 oxygens. And then we have 2 hydrogens and an oxygen in our steam. Remember, it's hot, so it's a gas, not water. Now we need to have the same number of atoms on both sides. I have 1, 2, 3, 4, 5, 6 carbons compared to only 1. So that's not balanced at all. And I have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens compared to 2. So we're going to do the O's last. Let's start with the C's. 6 carbons on this side. There's only 1 here, so I'm going to put a 6 in front. That gives me 6 CO2s. 1, 2, 3, 4, 5, 6 CO2s. So 6 carbons to go with the 6 carbons. So my carbons are balanced. Now I have 8 hydrogens. Over here I only have 2. So what do I want to put in front? You're correct if you said a 4. So now I'm going to have 4 steams. 4 steams. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens to go with the 8 hydrogens. My hydrogens and carbons are balanced. Thumbs up. Now it's time to fix the oxygens. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 oxygens. 16. So what's going to go in front? An 8. Yes, so 2 O2s, 3 O2s, 4 O2s, 5, 6, 7, 8 O2s. Now, drawing a picture takes a while. So, another way to look at these reactions without the picture is just to multiply. 6 carbons, 6 times 1 is 6 carbons. 8 hydrogens. 4 times 2 is 8 hydrogens. And I have 8 times 2 is 16 oxygens. 6 times 2 is 12 oxygens plus 4 times 1. So 12, 13, 14, 15, 16 oxygens on this side. So as you get better and better at balancing, you don't have to draw a little picture anymore. Let's try another one. Here I have a double replacement reaction that we're going to balance. Double replacement reaction. Now, notice in this reaction I have CO3 and NO3. Those are polyatomic ions. We're going to balance them as a group. So watch this. I have 2 sodiums, and I'm going to count this as 1 CO3 group. I'm not going to do C and 3 O's because I have CO3 on both sides. So if you have a polyatomic ion on both sides, balance it as a group. This is 1 CO3. Now I have 1 aluminum and I have 3 NO3s. Again, because I have NO3s on the other side, I can balance them as a group. 1 NO3, 2 NO3, 3 NO3s. Now it has to be equal to an Na and an NO3 on this side, plus 2 aluminums and 3 CO3 groups. 3 CO3s, 2 aluminums. Alright, nothing's really balanced. We can start wherever we want. There's no right or wrong with double replacement reactions. It's a double replacement reaction. Let's start with the aluminum. Why not? Here I have 1, here I have 2, so I need to put a 2 in front. That gives me a second AlNO3 3. The 2 goes to the whole thing. So this is 1 AlNO3 3 and 2 AlNO3 3s. Perfect. So I have 2 aluminums to go with 2 aluminums. Now I have 1, 2, 3, 4, 5, 6 nitrates. NO3s is nitrate. So I need to put a 6 in front. So there's 2, 3, 4, 5, 6. I have 6 NaNO3s. 1, 2, 3, 4, 5, 6. That gives me 6 nitrates to go with the 6 nitrates. Now, let's follow up with the sodiums. I have 6 sodiums. Over here I only have 2. So what am I going to put in front there? What goes here? Yes, a 3. 3 times 2 is 6 to go with the 6 sodiums. So there's a second Na2CO3 and a third Na2CO3. So 1, 2, 3 Na2CO3s. 6 sodiums to go with the 6 sodiums. Gives me 3 carbonates, and guess what? 3 carbonates. Alright, let's double check everything again. 6 sodiums, 6 sodiums. 3 carbonates, 3 carbonates. 2 aluminums, 2 aluminums. 3 nitrates, 3 nitrates. Again, we don't have to draw a picture. Let's just look at this reaction. I've got 3 times 2 is 6 sodiums. There's 6 times 1 is 6 sodiums. I've got 3 CO3s. I've got 3 CO3s because there's a 1 in front here, right? It's just a 1. Got 2 aluminums. I've got 2 aluminums. 1 times 2 is 2 aluminums. I've got 2 times 3 is 6 nitrates. I've got 6 nitrates. So as you get better, you don't have to draw the picture as you get better and better at this. Alright, so there's 2 more difficult reactions that you've seen me balanced. Good luck, GCC, with balancing your reactions. Bye-bye. See you later.